Alright, welcome to the video on questions 7 and 8. Question 7 says the function f is given by f of x equals x squared minus 6x plus 13. So this is standard form of a parabola. It says x is greater than or equal to 3. We'll take a look at that later. Alright, so first of all, here's the function. It says write it in this form. If you watched the video on the previous problem, you'll remember that this is called standard form and this is vertex form. And the way to change from standard form to vertex form is to complete the square. So let's try that now. Here's your original function. Sometimes it helps to rewrite it with a y instead of an f of x. So I just rewrote this with a y. And then I took that 13 and I moved it over to this side, so minus 13. The reason I moved it is because we're going to make a perfect square here, and sometimes it's easier not to have that extra number kind of getting in the way. So to make a perfect square, we need to find the number we're going to add here in order to make this a perfect square. To do that, you remember it's b over 2 squared. B value is negative 6. Divided by 2 is negative 3. And then square that. Negative 3 squared is 9. So the magic number is 9. We're going to add 9 here. We're going to add 9 here. So we're going to add 9 here to create a perfect square. And over here, we're going to add 9 as well to maintain the balance on both sides. When you add this, you get negative 4. On this side, this is a perfect square. Perfect square factors easily, and it always factors into something like this. So that factors into this. Remember, it's the square root of that, this sign, minus, and the square root of the last part, 3. So there we have it. If you multiplied this back out, you would get this. Now I'm going to move the 4 over, just to make it look like that in vertex form. Alright, and now's our goal, to write the equation in that form, and that's exactly what we did. Now b says find the inverse function. So the inverse, if you remember, is you just what's the word I'm looking for? Swap or exchange all the x and y values. That will give you the inverse. So I've taken the original function, but actually, if you took this one here, it would be harder to find the inverse. This one, we've converted to this form. It's actually easier to find the inverse of this. Even though the inverse of that and that are the same, because these are the same function, it's easier to work with this in terms of the algebra. So I'm going to use this function here. I'm going to swap or exchange the x and y, and notice now it's x equals, and the y is here. So now you're going to rearrange this to solve for y again, so you have the inverse function. So x minus 4, I move that 4 over. Then take a square root on both sides to get rid of the square. So now I have square root of x minus 4 equals y minus 3. Now I'm just going to move that 3 over to isolate the y. So the 3 went up to that side, and I actually wrote it like this here. So this is your inverse function, which you can then write with the proper notation, f to the power negative 1. Well, that just means inverse. So here's your inverse function. Okay, C says state the domain of the inverse. Alright, if this wasn't clear from the last couple of tests, make sure you really listen carefully now and think about it. When you take the inverse of a function, you swap all the x and y values, right? Just like I did here. I rewrote this with the x and y interchanged. So if a function, if you swap all the x and y values, think of the domain. The domain is all the x values of a function. So if you're swapping all the x and y values, then the domain will become the range, which is all the y values of the new function. Or the range, which was all the y values of the original, are now swapped and become the domain, which is all the x values of the other. So let me note that here. The range of the original function is equal to the domain of the inverse function, because the range is all the y values, and they swap over and become all the x values. So if we know that, we can give the domain of the inverse function by figuring out the range of the original. To get the range of the original, think about where the vertex is of this. The vertex is at 3, 4. So imagine this parabola graphed, and it has a vertex of 3, 4. So it would be kind of like over 3, up 4. So if this is the origin of here's your x and y axis, if this is the origin, you would go over 3, up 4, and then you draw a parabola. So that parabola has a range of, imagine that parabola sitting here and reaching up. It would have a range of 4 all the way to infinity. Again, imagine what a vertex is, and imagine the parabola sitting above that vertex, and so be all y values above 4 would be the range. So it'd be 4 to infinity. I'm sorry I don't have a little sketch of that, but a sketch would help. Basically sketch this one by moving the vertex to this and see what it looks like. There's your range, and the range of the original becomes the domain of the inverse, so therefore the domain of the inverse is that. Number 8, all right. This is a very easy problem, all right? At least part A is very easy. You look at this parabola that's given to you. It says you're given, the diagram shows part of a graph of this quadratic. It's given to you in vertex form. The graph has its vertex at P, okay, and passes through point A, okay, so it passes through this point. And the coordinates of A are 1, 0. Okay, great, that's 1, 0, that makes sense. So now you look at this and you're like, where's the vertex? Well, first of all, here's the function. That function rewritten in a vertex form. And we know the vertex is at negative 1, 2. So if you rewrote the function, this negative 1 becomes a 1 and 2. There's your vertex. So the vertex again is negative 1 and 2, and that allows you to create this function. So when you look at this function here, and the question is asking what is h and k, so what is h and k? Well, the h value must be negative 1, because if you put negative 1 in here, and then it's multiplied by negative, it'll become positive 1, which is what we have here. And k is just the y value of the vertex, which is right here. So k equals 2. Right, now let's do part B. Part B, we're going to use that point that was given to us. Because if we want to calculate A, we need to use this form, vertex form, and figure out what A is. So we need to put in everything else, replace the y, the x, everything with something else. So anyway, here's your equation. That's the equation of here in that form, in vertex form. So here's vertex form, but I've replaced this y with the y value of this point, because we know this point is on the parabola, so 0. I've replaced the x up here, that x is replaced with 1, because that's the 1, all right, of the point we know. So I've put the x and y values in here. Basically in here, right here, x and y have been replaced with those values. Now you can solve this. There's only one variable, it is a. We can solve it and get an answer for a. First of all, 1 plus 1 is 2, 2 squared is 4. So we have 4a plus 2. So I'll move the 2 over to that side, and that minus 2, and now I have a 4 divided by 4 on both sides. That can be simplified to negative 1/2.